Looking at the altitude of a triangle. And technically, there'll be three altitudes of a triangle. We have our coordinates, and I've put them over here on a graph. We have our triangle here, and don't worry about these equations. Just help us draw a triangle. An altitude of a triangle essentially is the height of a triangle. So what I'm going to do is I'm going to extend to the values and just kind of show this here. Here we go. And what I want to show you is the altitude of this triangle will have lines that are kind of outside the triangles. That's why I'm kind of extending it here, as you can see. And the reason being is the height of this side of the triangle would actually come down and be perpendicular to this side. So it's kind of outside the idea of the triangle. Same with this one here, probably be out here. And the height of this triangle would be here. So we're going to find the equations of these altitudes. So I've extended those two sides of the triangle just so you can see that it would cross. So in order to find the altitude of the triangles, we need to find the slopes of each side of the triangle. So that means we're going to be looking at AB, which we'll do in black, I guess. And we'll do BC, and then we're going to do AC. Okay, so we're going to have to find the slopes of all of those, and then the perpendicular bisectors to all those slopes. So for AB, let's find the slopes. Slope is usually denoted by M. So we'll take -4, subtract 8 over 5, subtract 2, which gives us -12 over 3, which is -4. Okay, in order to find the negative reciprocal of that, we'll put that as a fraction, and a line that's perpendicular to this would be positive 1 over 4. Okay, so we know our altitude would have the slope of y equals 1 over 4x plus b. We don't know what else from there. So let's repeat that process. Our BC, we're going to take our y value, -4, subtract 0, and 5, subtract 0, and that's going to give us -4 over 5. Okay, and -4 over 5, we need something that's perpendicular to that, so we need the negative reciprocal, so it's going to be positive. Oh, and I wrote that backwards. Sorry. It's going to be positive 5 over 4. So we know the equation of this altitude would be y equals 5 over 4x plus b. We'd like to figure out what our b, our y-intercept is. And again, repeat the process with C, AC. Our m, we'll take our y value, 8 subtract 0 over 2 subtract 0 is equal to 8 over 2, which is the idea of 4. We need, again, a perpendicular slope to 4, so we put 4 over 1. And to be perpendicular to that, we're looking at -1 over 4 in this case. So again, our altitudes, equation of our altitude is going to be y equals 1 over 4. Whoops, I wrote that wrong. It's twice I've done that now. Speaking faster than my mic can keep up. 1 over 4x plus b. So let's plug these slopes in just to see if they fit. Y equals 1 over 4x. That looks really good. In fact, it works out perfect. We'll explain why after. Another one was y equals 5 over 4x. We'll change them all to green so we can see our altitudes. That looks like it's going to be the right slope. And finally, negative y equals -1 over 4x. Okay, and I can see they're all going through the origin right now because we haven't given them y-intercepts, which is fine. We'll have to give all of them y-intercepts to see where these altitudes are. So, an altitude has to go through our opposite point. So for instance, AB, which was our 1 over 4. So let's kind of turn the other two off. Okay, our altitude right there, okay, is going through this coordinate. So this coordinate here, because this was our AB, it goes to our coordinate C. So in order to figure out our y-intercept, we have to plug in our coordinate C. So I'm going to take our C coordinate here, and we're going to plug it in. So we know that that'll help us find it. So we need coordinate C, which is 0, 0. And we're going to plug that in for the y and the x to help us find b. In this case, that becomes 0 is equal to 1 over 4 times 0 plus b. 0 being like a black hole, when you multiply, it gobbles everything up. So ends up, we did have the right equation. Our y-intercept actually ended up being 0. So we didn't write anything in. And perfect, it ran right through the opposite side. So here would be our altitude, the equation of our altitude. For BC, we got to use the opposite coordinate, and that would be our A coordinate. So our a being 2, 8, we'll write it here, a is 2, 8. We're going to plug those in for the x and the y, help us find our b. So we end up with 8 is equal to 5 over 4 times 2 plus b. This becomes 8 is equal to 10 over 4 plus b. When we bring that over, we get 8 over 1 minus 10 over 4 is equal to b. We need common denominators in order to add and subtract, so we get 32 over 4 minus 10 over 4 is equal to b, which gives us 22 over 4 is equal to our b value. So I'm going to leave it as a fraction and type that in. So our equation, sorry, I should write it all out here. Y is equal to 5 over 4x plus 22 over 4. So our 5 over 4 plus 22 over 4. And look at that, it crosses our opposite points, so that's perfect. That worked out great. There's our next altitude. And finally, the equation of our last altitude, well, that was from AC, so we're going to be using coordinate B to help us find our y-intercept. So B, we'll write it out as 5, negative 4. So we're essentially just repeating the same process. We plug these in for the x and the y. So we get negative 4 is equal to negative 1 over 4 times 5 plus b. Okay, this becomes negative 4 is equal to negative 5 over 4 plus b. We'll bring that to the other side. We get negative 4 plus 5 over 4 is equal to b. We need a common denominator, so we're going to multiply both the top and the bottom by 4, which gives us negative 16 over 4 plus 5 over 4 equals b, which means our b value is going to be negative 11 over 4. That's right, yeah. So our equation should read y is equal to negative 1 over 4 x minus 11 over 4. So let's write that last fraction in. Minus 11 over 4, and there it is. And if you notice something about all the altitudes, they all actually intersect. Though it's outside of the triangle, they all intersect out here. And the point is called the orthocenter. Okay. So really you only need 2 of them to find the orthocenter, but that's how you'd find the altitudes of a triangle. If you wanted to find the actual heights, you'd have to find out where these points intersect the equation of this part of the triangle. Okay, and for instance, this guy here, I'm going to turn off the orthocenter. And for instance, this guy here. And you'd be looking at the distance here. So you'd have to find distance formula there, distance formula there, and distance formula there. And depending on what is your base, your height of your triangle obviously is changing each time. So you have to really keep that in mind when going through this. Okay.